Okay guys, in this video we're taking a look at an actual AP multiple choice problem that requires U substitution. As you can see here, we have x squared over e to the x cubed, and look at the choices. They have some natural logs in there, which is tempting because we can see we have 1 over e to the x cubed. But let's see if that actually comes out to work out into a natural log. So the first thing, again, when you have a division, it is often helpful to just separate that so you get a clearer picture of what's going on. I have an e to the x cubed times x squared dx. And so again, how do I pick u? Well, I want to pick a function that's in the most complicated position. And I really have about 3 choices here. I can either pick x squared, which is not in a really complicated position at all. It's sort of just on the numerator and x squared. I could pick e to the x cubed, and I could pick x cubed as the exponent alone, okay? Which is in a pretty complicated position because it's in the denominator and it's part of the power of the function e. Now, I'm going to tell you right now, I'm going to go ahead and pick x cubed. And the reason I'm going to pick x cubed and not the whole entire e to the x cubed is because if I pick x cubed, its derivative, 3x squared, and again, don't worry about the coefficient, but the derivative x squared shows up right here. So that's a really good sign. The other reason I really don't want to pick e to the x cubed is because if I pick e to the x cubed and take its derivative, then let's assume we said u equal this. If I go to take the derivative for the differential, e to the x cubed, its derivative will be e to the x cubed times the derivative of x cubed, which is 3x squared dx. And now this is a kind of a complicated expression because it doesn't show up anywhere else. See, this is going to get replaced with u, this e, and then there's no more e's. So I cannot fix this by moving e to the other side because I don't have e's to replace. So I kind of come to a dead end if I let u equal the entire e to the x cubed. Okay, so I really don't want to do this. It's not going to allow me to complete the substitution. So I'm going to go ahead and x that out. That's not a good idea. And go ahead and focus on u equaling x cubed. If I take the differential, that'll give me 3x squared dx, which is good news. I have an x squared that I want to get rid of right here. And I have almost an x squared here. Let me go ahead and divide everything by 3 because I want that x squared dx. Same thing as multiply by 1/3. So now I have 1/3 du is going to equal x squared dx. That's perfect because x squared dx is exactly what I'm trying to replace. So 1/3 du will take care of that. All right, let me do my substitution. Already I know that I let u equal x cubed, so I will have 1 over e to the u times, and instead of x squared dx, again, I'm going to replace that by 1/3 times du. As in the previous videos, I can go ahead and take this 1/3 outside. And I'm going to send this u upstairs to the negative u. And now I'm left with u. Now, you cannot use the little trick that we sometimes use to say, oh, we're going to go ahead and add 1 and multiply by the reciprocal, because this is not a number, it's a variable, so you can't really add 1. But what you can do is remember this is a special function. E to the negative u is special because it's e to the something. And remember, the antiderivative of e to the something is always e to the something. So that is the correct antiderivative. But if I take the derivative of e to the negative u, it's going to end up multiplying by a negative, which is going to give me a negative result, but I don't have a negative result here, so I need to add that extra negative so that it gives me a positive result as I have here. Remember, the antiderivative, when you do its derivative, should give you this function here. I also have a 1/3 to worry about, so let me just rewrite that. It'll be negative 1/3 e to the negative u plus c. And before I replace my u, I just want to go back and say the antiderivative of e to whatever is e to whatever. But if that whatever has a number in front, which it does, -1, I got to make sure that I put something in place in front of e so that when I do take that derivative again, it disappears. And in this case, I need to make that negative disappear, and I can simply do that by multiplying by another negative. Now it's time to replace that u with x cubed, and so I get negative 1/3 e to the negative x cubed plus c. Okay, now if you look at our options, we don't really see any of them that sort of stick out as being exactly like what I have. So it's definitely not the natural log one. Remember I said that kind of looks suspect. So we're looking at, all right, this one could be, but it's not. It's the negative is there, the 1/3 is there, but the negative up in the power is not there. And so we're left between these two. So let's see, this one kept an x cubed on top. I don't really have that. So, and my answer is supposed to be negative, so that's definitely not it. If you notice, all they did here is send that e to the negative x cubed downstairs, which makes it now a positive power. I still have my negative, I still have my 1/3, and I still have my plus c. So in this case, c is the answer. Alright guys, that is my 5th example. Hopefully by now you guys are pros. If you have questions, concerns, you want to send me your work, text, email, and I'll give you I'll mark it up and send you some information. We will go over some more stuff on Monday, but it's very important that by now you're feeling pretty confident on this. See you soon.